Okay, so I wanted to go over just briefly a little bit on the burner itself. A couple of reasons behind this. One is I have a couple of comments about one, how durable they are, how long are they going to last, what does it cost to replace it. I've given some prices on replacement of around $1,800 a piece. Like, wow, that's a lot of money. Well, the fact of the matter is there's a lot of stuff in the burner itself. So this is the finished product, if you will, as you've seen it in the burn machine itself. We put a lift hook on here so you can lift it up. It is fairly heavy. It has refractory material here cast in place. But to give you an idea, it starts out, just move this out of the way. It starts out as a plate. And the plate has about 45 holes in it. And they're in a pattern, 3 and 4, offset this way, offset that way. These are all a little bit bigger than 1/4 of an inch. After we make the plate, we make a box. Here's one side of the box. You can see the other side of the box. And then there's 2 pieces that go down on top and they get welded in place. As well, there's a pipe that gets welded in place. So before this piece is ready to go, we take about 45 nozzles and they're welded in place. The length and diameter of this nozzle is important because it's what keeps the flame from going back into this box. This box here basically has propane and air in it in the proper mix that it will burn. So you do not want flame going back in through the nozzle. So these nozzles increase the velocity of the air such that the air speed is greater than the flame front speed. What's the flame front speed? That's how fast flame will move in a properly mix of propane and air. It has a travel speed. As long as the blowing out is faster than that speed, it won't go inside. In addition, this is a 12 gauge steel box. It can withstand about 500 psi before it blows up. If the fuel in this fuel air mix was to ignite and it would go poof, it only builds up to about 60, 70 psi. It's not like a car engine where you're compressing a fuel air mixture and then igniting it. This is just air basically under about 0.5 psi with fuel in it. And if it should ignite, then it would just go poof. We had it do that before we added these in there, so we know what it sounds like. After the nozzles are installed, actually what we do is we weld in several pieces of angle. Actually, this one's too long, but we put angle pieces in here and we put a lath over top. We kind of break out the holes, push this down on top of there. This is so that when we pour the refractory material on top, it stays tough and rugged. Virtually all refractories, once they're heated up into in a situation like this, or in a boiler, or in a wood stove, or many other devices that use the refractory, the refractory material does crack. And in fact, when I had the other piece over here, I'll bring it back. You can look closely. There are some cracks in it. However, because we have put this lath material and these angle pieces embedded in it, even though it has a crack in it, it's hard, it's firm, it's not going to fall apart. It's kind of like putting a rebar in concrete. Well, in addition to that, we have this valve. When we looked at the gas distribution system before, we saw that these pipes went up vertically and then they go into here. So on the side of the machine, we have air coming through here from the blower for combustion air. And inside, we have this little device that's got 2 holes in it. So gas comes in through here, propane, natural gas, LP. As the air comes up through here, gas comes out of here. That gas is shut off by the simple little shut-off valve here. This is when we shut down the machine. That can turn it on and off, but it also has a little needle valve here. And this needle valve can determine how much gas comes out of this nozzle versus, say, burner number 2 or burner number 3 or burner number 4. Once it exits out of here, we've also put together a little bit of a static mixer. So this is down inside the pipe, just above where the gas is. And as the gas and air comes up, it swirls it around and mixes it. So we're trying to blend the fuel and the air so that once it comes up inside this box, there's not hot spots on one side or the other. It's all a uniform blend of fuel and air coming in through the pipe, into the box, and on down. Further to that, this pipe, as it goes into this unit from the front, although you can't see it, it comes into the front, goes all the way to the back. It has holes in it to force the fuel-air mix to the side, as well as some to go straight down. Again, it's all an attempt to get a uniform flow out of each one of the nozzles so that you get a uniform burn. And when we look up at the end of the burner machine, when the burn is in operation, you'll see pretty much all those nozzles, all 40, 45 of them, have all got a nice flame. They all have a similar amount of yellow on the bottom. We try to keep it mostly blue. When it's blue, it is a lean mixture and it's hot. When it's got a lot of yellow on the bottom, it's a little bit rich and it's not as hot. So that's a rundown on the burner and a replacement. We've had these burners now operating, I guess the longest one's about 3 years, and they're still operating. So if you're running a machine 24 hours a day, 7 days a week, I'd be hard pressed to say how long they'd last, but we have them in 8-10-hour operations, and they've lasted at least 3 years. Replacement on it is, as I said, about $1,800, and this is a particular refractory material. The refractory material keeps the metal from getting too hot, and it gives a nice uniform heat emitter, if you will. The top of these burners gives a uniform heat to the whole surface of the lumber as it goes through. So that's that. I think